5.4 Sum and Difference Formulas. So here are the formulas you need to memorize. So you need to remember. You need to memorize because they will not be provided to you on the quiz or on the test. So here we go. Sine of u plus v is equal to sine, cosine, cosine, sine. So it's going to be sine of u cosine v plus sine, cosine, cosine, sine. So cosine u, sine of v. So notice what we have is u, v, and it's going to be sine, cosine, cosine, sine. And then notice that the sign of the sines are the same. So if you're adding, you have an addition sign there. So if you have a subtraction, it's going to be also a subtraction sign here, and it's sine, cosine, cosine, sine. So sine, it's again uv, right, or you have uv, but that middle, right, operation symbol stays the same. When you have cosine of u plus v, it's going to be cosine, cosine, sine, sine. So notice here you still have the uv happening, but for cosines, it's going to be cosine, cosine, sine, sine. Not like cosine, cosine, sine, sine. And their operation symbols are going to be opposites. So when you have a plus here, you're going to have a minus. So one way I like to remember this is, other than like the little rhyme, sine, cosine, cosine, sine, cosine, cosine, sine, sine, I like to just remember it like cosine and cosine. See how they get to stay with their same kind, like cosine, cosine, and sine. So they have to, so they don't get to be with the same operation symbol, right? Because they get to be with cosines and cosines, sines and sines. They have to have like different operation symbols. For sine, cosine, cosine, sine, other than remember the little rhyme, because the sines and cosines don't get to stay with each other like they do with cosine, cosine, and sine, sine, or cosine and cosines are different functions and they're right next to each other, they get to keep the same symbol. So pluses stay plus, minuses stay minus. Okay, so what would cosine of u minus v be equal to? Cosine of u minus v. Cosine of u minus v would be, right, cosine would be cosine, cosine, sine, sine. Again, you have uv, always in order. And what would the operation symbol be here? Would it be a minus or a plus? Okay, the operation symbol is going to be different here, right? Because cosines and sines got to stay together, the operation symbols are going to be opposite. So somebody has to be opposites. Somebody has to be different, either the sines and cosines are different and the operation symbol stays the same, or cosines and sines are the same and then the operation symbols are different. When you have tangent of u plus v and tangent of u minus v, right, so you have a sum of a tangent and a difference of a tangent, then what you end up with is a quotient. You're going to have a numerator over denominator, right? The numerator is going to keep the same sign, S-I-G-N, as what you see. Okay, so if you have tangent of u plus v, you're going to have tangent of u plus tangent of v. If you have tangent of u minus v, you're going to have tangent of u minus tangent of v. The denominator is going to have an opposite sign here, right? So if you had a plus, you have a minus. If you had a minus, you have a plus. You always have a 1 right here. You're going to have a 1. And then for the second term, it's going to be a product of the two. So you're going to have a product. So it's going to be tangent u, tangent v. So tangent u, tangent v. Tangent u, tangent v. Okay, let's go ahead and recap. So you have sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? Same signs for sines, opposite signs for cosines. And then for tangent, you have tangent of u plus v is tangent of u plus tangent of v. Tangent of u minus v is tangent of u minus tangent of v. And it's always 1 and something. It's going to be 1 and the product, right? Tangent of u, tangent of v. And then the signs in the denominator are going to be opposites. So when you had a plus, you have a minus. When you had a minus, you have a plus. One thing I want you to know, it's not part of like your formula memorization, is that tangent of u plus v is also equivalent to, right, sine of u plus v over cosine of u plus v, right? Because you have like sine over cosine equaling tangent as long as the angle is the same, right? So same thing here. Tangent of u minus v is equivalent to sine over cosine, where the angles on the inside match up. So depending on the situation, it might be easier to take that approach, but you definitely need to know this portion of the sum, right? Sum and difference formulas. Here's an example problem. Find the exact value of cosine of 75 degrees. And you do not get to use your calculator. How would you do this problem? Because 75 degrees is not on your unit circle. Notice that even though 75 degrees is not on your unit circle, we can break apart 75 degrees to two angles that are on the unit circle, like 30 degrees and 45 degrees. So I have cosine of something degrees is equal to cosine of something plus something. So this is going to be like your u, and then the 45 degrees is going to be like your v. So note that cosine of 30 degrees plus 45 degrees does not equal cosine of 30 degrees plus cosine of 45 degrees, but it's going to be cosine, cosine, sine, sine. So I went ahead and put in my sum of the cosine into my sum formula, right? So cosine, cosine, sine, sine, where my u is 30 degrees, my v is 45 degrees. And because, right, it's going to be minus, it's going to be opposite and sign in the middle, right? Cosine's got to stay together. Therefore, the operation symbol is going to be different. And now what you do is you're going to replace cosine of 30 degrees with its ratio. Same thing with cosine of 45 and so forth. So cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2, and you multiply them. Minus sine of 30 degrees is 1/2. Sine of 45 degrees is root 2 over 2, and you're going to multiply them. What happens when you multiply? You multiply straight across, right? Root 3 times root 2 gives you root 6, and then 2 times 2 gives you 4. Minus 1 times root 2 is root 2, and 2 times 2 is 4. So you can have as your final answer root 6 over 4 minus root 2 over 4. Or if you were to rewrite this as a single fraction, you would have root 6 minus 2 over all over 4. Note that root 6 and root 2, they're not like terms, so you cannot combine them. Okay, you go ahead and try this problem now. Find the exact value of sine of 15 degrees. So the first thing you want to think is, because 15 degrees is not on your unit circle, right? How could you rewrite 15 degrees in terms of two angle measures that are on the unit circle, whether you're adding two angles or subtracting them? So you could have done like 45 minus 30 degrees. You could have done like 60 degrees minus 45 degrees. You could have also done 135 degrees minus 120 degrees. So you have lots of different possibilities where you have two angles that are a part of the unit circle such that either their sum or their difference gives you the angle that you're looking for. Okay, so once you have your two angles here, that's like my u minus v, I'm going to have the sine formula. So I have sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Then I have the uv, uv, and I have the same sign. When you have sines, you have the same sign. Okay, so I can go ahead and substitute each of those trig functions. So I had like 4 of them that I had to substitute, right? So it's like 4 quick problems in one. And then I multiply straight across, so I get root 6 over 4 minus root 2 over 4. Again, you can leave your answer this way. Or if you wanted to write it as a single fraction with a common denominator, it would be root 6 minus root 2 all over 4.